Now, we do have confirmed estimates out of the United States Geological Survey putting the expected quake at a 10.0. An evacuation order has been...
You may find it hard to believe, but what you see on the screen right now isn't just one place. In fact, this is the place where the Pacific Plate and the North American Plate lie adjacent to each other. So if you visit this place with a friend, both of you can be in the same area but stand on two separate tectonic plates. But what is this place? Well, it's the infamous San Andreas fault line of California, and possibly the potential origin point of one of the greatest disasters in the history of California. It is rightfully considered the greatest threat faced by Southern California today. But how is that possible? To better understand this fault line and the danger it poses to unsuspecting Californians, first you need to find out a bit more about its geography. So what exactly is the San Andreas fault line? The sci-fi and apocalyptic movie fans amongst you must have an inkling about this thanks to the popular film titled San Andreas, featuring everyone's favorite Dwayne Johnson. Though the depiction of disaster in case of a rupture is far more exaggerated in this film. The San Andreas fault line is what we call a continental transform fault extending through California. It's roughly 1,200 kilometers long. The fault forms the tectonic boundary between the Pacific and North American plates. Its motion is described by experts as a right lateral slip motion, which means that the two plates are slowly sliding past each other horizontally. The fault is divided into three distinct segments, each one bearing its unique characteristics. Another important distinguishing feature of the three segments is the varying degree of earthquake risk. The slip rate between these fault lines is between 20 to 35 millimeters per year. It was first discovered by a UC Berkeley professor named Andrew Lawson in 1895. Initially, he discovered the northern zone of the fault. Most people believe it had been named after the small lake that formed in the valley between the two plates called the San Andreas Lake. But reports by Lawson published between 1895 to 1906 suggest he was the one who named it after the surrounding San Andreas Valley. The 1906 earthquake that occurred in San Francisco led Lawson to deduce that this fault extended all the way into Southern California. Thomas Dibble, a geologist, came to the conclusion that hundreds of miles of lateral movements could occur along this fault. Experts believe this major fracture in the Earth's crust began forming in the mid-Cenozoic era almost 30 million years ago. Tectonic movement along this fault has been related to multiple large earthquakes originating close to the surface along its path. The plate tectonics theory proposes that San Andreas represents the strike-slip boundary between the Northern Pacific and North American plates. The Northern Pacific Plate is apparently sliding laterally past the North American Plate in the northern direction. The three segments of the fault are called the Northern, Central, and Southern segments. The northern segment runs from Hollister and terminates at Mendocino Triple Junction. The central segment runs northwest from Parkfield to Hollister, and the southern segment stretches from Parkfield to the Salton Sea. Geologists have explained that the southwestern movement of the North American Plate towards the Pacific Plate is creating compressional forces along the eastern side, while the northwest movement of the Pacific Plate is also producing significant compressional forces that are particularly pronounced at the point where the North American Plate has forced San Andreas to jog westward. A great majority of the Californian population resides in the vicinity of this fault, and a few towns, cities, and roads are even built on it. A tunnel of the Bay Area Rapid Transit System of San Francisco is bored exactly through the fault area. Slippage of the plates doesn't happen annually. Instead, the pressure from the compressional forces builds up over many years and finally slips in the form of one significantly large earthquake. And these earthquakes are the reason why scientists are always worried about these fault lines. It's quite evident that most of this fault line is covered by development, which means the people residing here are constantly at risk. Driving north from Los Angeles on Interstate 5, you will reach the Tejon Pass, which runs exactly along the fault line. And if you want to see the artifacts of this fault with your own eyes, this is the place to be. Here on the roadside, one plate scraping past the other is clearly visible. The gray metamorphic quartz monzonite you see here belongs to the Pacific Plate, while the rich brown sediment sandstone and siltstone are from the North American Plate. It's not possible for these two rocks to have formed together on their own. It only happened because of the sliding movement of the two plates. Between the two layers is a layer of black rock, also called fault gouge, and this is where the actual fault line is. If an earthquake were to hit this area, it would probably sever the Interstate 5 and completely cut the major transportation route to and from Los Angeles. Continuing north into the Central California Valley and then turning west, you will reach the Carrizo Plain. Thankfully, this is mostly a rural area with little to no development over the fault line, but the best place to see the fault line is the Elkhorn Scarp from above. At this place, quite an evident dip between the borders of the two plates is visible. Interestingly, the shifting of the plates also leaves its marks on the local waterways. Creeks crossing the fault line tend to have their courses altered with the movement over years. Seismologists have explained that a major release of stress in the southern portion of the San Andreas fault system hasn't occurred since the year 1857, and therefore it's only a matter of time before the fault generates a large-scale and potentially destructive earthquake. But when is this going to happen, and what has made the experts think that it will happen? A few years ago, Thomas Jordan, the director of the Southern California Earthquake Center, made a bone-chilling announcement. According to him, the San Andreas Fault is apparently in a critical state and can generate a huge earthquake at any moment. He said that the southern portion of the fault line looks locked, loaded, and ready to go. The eminent seismologist explained that despite the fact both plates are moving in an approximately northern direction, the Pacific plate is moving faster than its counterpart and is thereby causing the stress to build up constantly. Some of these stresses were released in the 1906 catastrophic earthquake that hit San Francisco Bay Area and again in the 1989 Loma Prieta earthquake. But south of the fault line, the state has remained safe from such events. This has led the experts to believe that an earthquake is imminent, and by the looks of it, this is going to be a big one. Catastrophic earthquakes are bound to happen every 200 or so years, according to the US Geological Survey. However, we still can't predict when these will happen exactly. But in the case of the San Andreas fault line, we do know one thing for sure: an impending earthquake will cause massive amounts of destruction. The middle section of the San Andreas Fault is now prone to much larger earthquakes than previously believed. Between the towns of Hollister and Parkfield, the fault undergoes an aseismic creep. This means here the two sections of the fault move imperceptibly and release the stress, thereby avoiding any large magnitude earthquakes. But researchers have found out that in the past, this section may have experienced some high magnitude earthquakes. According to Genevieve Kofi, an earthquake geologist at GNS Science in New Zealand, the large quakes on this part of the fault probably occurred within the last 3 million years. She also believes that even if the stress doesn't build up to the point where it causes a massive earthquake here at the fault, it could act as a conduit for the quakes originating at the northern and southern section of the fault line. While it's hard to accurately predict when the massive big one might hit, the seismologists make a point of releasing a forecast of the likelihood of such an event every few years to keep the public vigilant. More than a decade ago, seismologists modeled how the ground would shake on the southern part of the San Andreas Fault, and environmental scientists and engineers use this data to estimate the effects of a hypothetical earthquake of 7.8 magnitudes. Their speculations and various other models have predicted that the effects of such a quake in California will be catastrophic, to say the least. So what will happen if it cracks and the big one finally hits the Coachella Valley? Let's begin by looking at this earthquake simulation developed by the California Academy of Sciences. You can see here that San Andreas might be the source of a lot of movement detected in the Bay Area, but multiple other fault lines also cut through the coastal part of California, forming a complex network of potentially hazardous fractures. The Hayward Fault runs almost parallel to the San Andreas fault line, and it accounts for a good amount of movement between the two plates. Hayward has barely shifted since its 1869 earthquake. This simulation will show you what may happen in case just 50 miles of any fault running through California ruptures. It would trigger an event having around 1/16 the intensity of the 1906 San Francisco earthquake. The ground movement it may cause will vary depending on the proximity of the mountains, the type of soil, and other factors. Using these factors, scientists calculate the shaking intensity of the quake. Now you can see the effects of a 9.2 magnitude earthquake from the Cascadia fault line, and it was felt all along the Pacific coastlines. You can see when it hits Hawaii, and then Hawaii reverb rotates the wave to the west coast. a tsunami makes its way to Indonesia, Asia, New Zealand, Australia, and Latin America. Experts believe the big one will hit the state with an almost similar force. That in the upcoming 3 decades, there's a 99% chance of an earthquake of a magnitude 6.7 or greater hitting California. And there's a 46% chance that this earthquake will be of 7.5 magnitude or more. The recent predictions limit the magnitude of this imminent earthquake to 8. Devastation in any case will be a given. According to the 7.8 magnitude hypothetical model, with slippage of 2 to 7 meters, the construction straddling the fault will be most severely affected. However, thanks to the Alquist-Priolo Earthquake Fault Zoning Act, constructions in this zone are few and far apart. But besides the construction, this earthquake will affect around 90 fiber optic cables, 966 roads, 39 gas pipes, and 141 power lines crossing this zone. The damage to buildings will cost around $33 billion, with the more modern buildings sustaining lesser damage than the older ones. Experts also expect raging fires just like the ones after the Northridge earthquake. In fact, the estimated damage these fires will cause is probably going to be greater than that caused by the initial ground shaking. Experts believe the overall death toll will be between 1,800 and 2,000. Hundreds of fires will start, roads will be blocked, the water system will be severely damaged, and the emergency personnel will face difficulty in putting out all of the fires. The lines bringing water, gas, and electricity to Los Angeles will be severed and won't get fixed for months. The modern buildings will survive the quake but will be rendered unusable. Aftershocks will keep shaking the valley in the coming days and may lead to further destruction. Lucy Jones, a USGS seismologist, thinks this is somewhat of an underestimation. According to her, the fire damage after the earthquake is surprising, but it could be much worse in case these Santa Ana winds are blowing when the earthquake hits. These are seasonal winds that blow dusty, dry air from inland to the coast and will gravely increase the risk of wildfires. The Los Angeles water reserves wouldn't last more than 6 months and would result in a severe drought. The overall damage can amount up to $200 billion. Around 50,000 people will get injured and 2,000 will die. Lucy said that it's not so much about dying in the earthquake, it's more about being miserable after the earthquake, and people might just give up on Southern California. Everything the population relies on would be damaged, and it will take more than a year to fix it all. In the absence of functional infrastructure, the economy will probably collapse, and people will just abandon this part of the state, including Los Angeles. To summarize, when the big one hits, Southern California is going to be massively affected and the damage will be significant. However, Californians aren't strangers to the devastation caused by the ground shaking, so maybe the consequences won't be as drastic as Lucy Jones has speculated. Many experts at the Pacific Northwest Seismic Network also speculate that such earthquakes can cause aftershocks that could trigger tsunamis. These tsunamis will send massive waves of water crashing onto the land and will eventually lead to flooding. In fact, a phenomenon called seiche can cause smaller water bodies like pools to launch powerful water waves. And when we say infrastructure will sustain unfathomable damage, we don't just mean buildings. The bridges may end up warped, train tracks will twist and delay the help from outside, and highways won't remain usable. Public transport will suffer immense damage, and there will probably be little to no transportation in the weeks after the event. First responders, fire trucks, and ambulances will also face significant delays among other obstacles. The 1857 Tejon earthquake ruptured nearly 350 kilometers in southern and central California. Although it's called the Fort Tejon quake, its epicenter was located just south of Parkfield. The magnitude of this earthquake was recorded to be 7.8 and resulted in the deaths of 2 people. In 1906, California wasn't as lucky, and a 7.8 magnitude earthquake ruptured nearly 340 kilometers in northern California. The epicenter of this one was near San Francisco, and the damage it caused was monumental. Northern California was hit by this major quake on April 18, 1906. High-intensity shaking was felt from Eureka to the Salinas Valley. Fires broke out soon after the quake, and it took the authorities several days to put them out. It is remembered as one of the deadliest earthquakes in the history of the United States. It destroyed more than 80% of the city and killed more than 3,000 people. The death toll of this event is considered the greatest loss of life from a natural disaster in California. Property losses worth $400 million were suffered by the state in 1906, which amounts to more than $8.5 billion today. Another earthquake hit San Francisco on March 22, 1957. It was a 5.7 magnitude quake and considerably less severe than the 1906 one. The financial losses from this one amounted up to $1 million, and only one person died in this quake. The epicenter of this earthquake was the San Andreas Fault in the ocean west of San Francisco. In 1989, the Loma Prieta earthquake ruptured almost 40 kilometers near Santa Cruz, California. 63 people died in this event, and moderate damage was sustained by some vulnerable locations in the Bay Area. The magnitude of this quake was nearly 6.9. The most recent earthquake in the region occurred on the 24th of September 2004. The 6.9 magnitude quake shook the Parkfield area, but the aftershocks continued for a week after the main event. The kind of movement occurring along the fault plays a major role in these earthquakes. Blocks on the opposite sides of the fault tend to move horizontally as already established. If you stood on one side of the fault and looked across it, the block on the opposite side would appear to have moved to the right side. In the 1906 earthquake, roads, fences, and rows of trees and bushes crossing the fault were offset by several yards. The roads crossing Tamales Bay were offset by almost 12 feet. In each case, the ground west of the fault noticeably moved relatively northward. Sudden offset capable of initiating an earthquake occurs in one section of the fault at a time. The total offset unevenly accumulates over time, primarily by movement on the first one, followed by movement in another section of the fault. The sections that produce massive earthquakes remain locked and silent for more than a century, allowing the strain to build up, and then this strain is released in great lurches in the form of huge earthquakes. Other stretches of the fault are accommodated by the creeping movement instead of generating sudden earthquakes. According to geologists, the total displacement accumulated from this movement and the earthquakes is around 350 miles along the San Andreas Fault since the time it came into existence nearly 20 million years ago. Segments of the fault between the Tejon Pass and the Salton Sea have been studied in detail by experts who have found geologically similar terrains on opposite sides of the fault that are now separated by 150 miles. Some crustal blocks may have moved through 20 or more degrees of latitude. There are many segments along the Earth's plate boundaries like the San Andreas where large earthquakes haven't occurred in a long time now. Scientists call these segments seismic gaps and have achieved a bit of success in estimating when some of these gaps will produce earthquakes. Geological studies have revealed that in the past 1,500 years, earthquakes have occurred at intervals of about 150 years on the southern part of the San Andreas Fault. And according to this estimate, the last massive earthquake on the southern San Andreas occurred in 1857, so the next 30 years are probably when the next one will happen. The San Francisco Bay Area is at a lesser risk as it has been less than 150 years since the 1906 earthquake. However, the area is still susceptible to potentially hazardous, moderate-sized earth-rattling events that can occur at any time. Experts are, however, optimistic that large-scale events won't occur without a premonition. Such an earthquake will be preceded by several years of increase in seismic activity and will possibly include multiple aftershocks of magnitude 5 along the San Andreas Fault. Seismologists also think they will record evident changes in the Earth's surface before a massive earthquake. These changes might include shortening of survey lines across the fault, changes in elevation, and effects on the strain meters deployed in various wells. A section of San Andreas near Parkfield, Central California, is considered a key area for research methods employed in earthquake predictions. This is because moderate-sized quakes have been rattling this area every 20 to 22 years for nearly a century now. Since the Great Earthquake of 1966, Parkfield has been vulnerable to a magnitude 5 to 6 earthquake, and one did occur in 2004. Besides the San Andreas, the long and lethal Hayward Fault, slicing along the base of the Berkeley Hills and directly through the University of California, is also a ticking time bomb. It passes under a theater, a few dormitories, and the California Memorial Stadium steps. Scientists already know that the Hayward inches along steadily, but they also know that faults don't only creep, they also rupture and break, and this rupturing will happen suddenly without any prior warning. A Berkeley professor named Richard Allen has stated that Hayward is a particularly dangerous fault line. It hasn't set off an earthquake since 1868 and is therefore scheduled for a major earthquake in the near future. Allen believes that an earthquake in Hayward will entirely liquefy the stadium field. Acclaimed experts have made it clear that massive earthquakes are an undeniable reality that Californians cannot stop from occurring. But what the locals can do is be prepared for such a calamity. California is developing 3 major lines of defense against a hazardous earthquake. Buildings in earthquake areas should be designed and built to resist the rattling movement. Lucy Jones spent all of 2014 working with the then Los Angeles mayor's office to identify vulnerabilities and prepare the city for the inevitable. Building codes for older structures can be changed to require retrofitting so that they would withstand the shaking. In some cities, programs to strengthen or tear down buildings prone to collapse have been underway. The second line of defense involves the selective use of land in order to minimize the hazardous effects. Power, communication, and internet systems should be strengthened, and there should be backup systems to ensure that communication isn't entirely cut off in case of an earthquake. It isn't as easy as it sounds. Such plans require billions of dollars in financing and several decades to implement. There are many obstacles in the way of improving the ability of populated areas to survive a catastrophic earthquake. Homeowners can help themselves and make efforts on an individual level. They can retrofit their properties to better hold up in case of a severe earthquake. Fire extinguishers should be installed everywhere it's possible, including in homes and cars. They should also be included in the earthquake kits. Putting out little flames before they grow and spread can save a lot of lives, property, and money. Schools, businesses, and residential neighborhoods can hold shakeout drills in order to practice what they'll have to do when an earthquake occurs. It's also important to not pay heed to the earthquake myths and live in constant fear. Geology reports have confirmed that when the big one hits, California is not going to break off from the US, and it definitely won't slide into the sea. The over-sensationalized version of doomsday in popular fiction is mostly an exaggeration. Staying safe during an earthquake is something every individual will have to do on their own. While the ground is shaking, it's better to remain stationary and get closer to the ground by crawling under a table or other furniture if you're inside. If you move around during a massive earthquake, there's a good chance you'll get cut by glass shards or get hit by moving objects. The shaking ground might throw you off balance, making you fall, and you can sustain injuries as a result. Falling electrical wires and other debris can hit cars or people, and in case of a high-magnitude quake, it will take the emergency responders longer to reach the ones in need of help. People need to identify the safe spaces in their homes, and when the earthquake hits, just drop, cover, and hold on to each member of the household. It's also important to stock up on water and snacks, and ensuring there's some available in every room will come in handy too. A violent earthquake can rupture the surface of the earth, trigger landslides, and even liquefy the loosely packed, water-saturated soil, so people should also be prepared to evacuate at any moment. Experts can't pinpoint when the big one will happen and whether it will be as big as they're speculating it to be. But because California has experienced its fair share of earthquakes in the past, it's only logical that the locals take every step necessary to minimize the damage it can potentially cause. How long does California have, in your opinion, before the San Andreas fault line ruptures and triggers a lethal earthquake? Is it going to be as devastating as the experts think, or are they overestimating it? Tell us in the comments below.